just the basics. So why settle for 95% confidence when estimating an unknown parameter? Do larger random samples yield better intervals? All right. So why would we settle for 95% confidence instead of 99% confidence? So we're going to look back at that same applet we were looking at before with our confidence levels. So we're going to look at this interval. Why don't you guys go to this page in your book, wherever this activity is. This would be page 485. All right. Let's go, Donovan. Will you start us off, number 1?
Go to freeman.com/TPS5e and launch the confidence intervals applet. Use the default settings, confidence level 95% and sample size 10 equals 20.
All right. Now what? Yeah, keep reading. All right, so let's take a look at our length of our confidence intervals. Right now we're at 95. What are we going to, 99? What happened to the length of the interval, you guys? It increased, right? So when I was at 95, when I was at 99, right? So if I want to be more confident, what am I doing? Increasing that range, right? I'm less accurate. So what's the price we pay for greater confidence? Yeah, our range is a lot bigger here. So we're less accurate. Kind of like if I want to estimate the weather, right? If I want to give a really big range, I'm going to be more accurate than if I give a small range. All right, Ginger, what's the next part say? All right, what happens to the length when I go to 90, you guys? Okay, shorter. So I'm less confident, right? Less confident, but I have a much tighter interval, right? Okay, Jake, what's the next step? Say. Oh, you eating a granola bar there? Even shorter, all right? So same idea, the shorter or the less confident I am, the smaller the range of my interval. So the greater the confidence, boom, really confident, really small intervals, right? Less confident, really large intervals. Less confident, small intervals. Cool. All right, Malcolm, what's the next part say?
Summarize what you learned about the relationship between the confidence level and the length of the confidence intervals for a fixed sample size.
All right, so I would probably write something about that. If we're 80% confident, we have a smaller length of interval. If we're 99% confident, we have a larger length interval. Okay, so that's one way to change the length of the interval, is by changing your confidence level. Abby, what's step 6 say?
Reset the applet and change the confidence level to 95. What happens to the length of the interval that I've used?
All right, so there's my 25, and we have a sample size of 20. So what happens when I increase my sample size? I know, it all went away. I don't know if you guys could even see that difference, but all right, here's 20, and I went up to 75. What happened? Smaller intervals. All right, so it is more accurate. So another way to get smaller intervals is to increase the sample size. All right, so the larger the sample, the smaller the interval. Okay, and if we want to be less confident, the smaller the interval, right? 80% confidence, you can have a smaller interval. Cool. All right. So the price we pay for greater confidence is a wider interval. So if I have those three intervals and I want to be 80% confident, which one matches my 80% confident? Okay? Our smallest one, right? So we're less confident, smaller, and then we have our 90, and then we have our 95. So 95% confidence, again, wider interval. So taking the idea of confidence to an extreme, what if we want to estimate with 100% confidence the proportion P of all U.S. adults who use Twitter? 0 to 1, right? Talking proportions, so 0 to 1. I'm 100% certain that 0 to 1 would be the true proportion of U.S. adults who use Twitter. Pretty confident. Yeah, it's very useful. It's very helpful in our life. I'm 100% confident. All right, calculating a confidence interval. The confidence interval for estimating a population parameter always has the form, the statistic, plus or minus the critical value times the standard deviation of the statistic. We're going to get more specific in the next section, but the statistic is p hat, possibly, or x bar, all right? So that's what's given to you. So if I interview all of you guys and ask you what proportion of you are going to go to the Sadie Hawkins dance, I would put that decimal right there. That would be my statistic. It's on your birthday, so you're definitely going. Okay, and then plus or minus the critical value, we're going to come back to z-scores, all right, in this particular section. And then we have the standard deviation of the statistic, where if we're doing proportions, do you guys remember the formula for standard deviation? You do? Thanks, Ginger. What is it? Okay. Now, before we knew what P actually was, because P was the true proportion, right? So in this problem, since we can't use P, what do you think we're going to use? We will. We will use P hat. Okay? So we'll have to use the sample proportion instead of the true proportion for our estimate because we won't have the true proportion. Okay? Okay, the standard deviation of the statistic depends on the sample size n. So again, we're back to using that n value, which is why when we were looking at those graph things a second ago, when we increase samples, we get more precise estimates, which means less variability in the statistic, okay, which comes from that formula, right? The higher that number, the smaller we're adding and subtracting since it's dividing by. All right. So the margin of error, which is this distance right here, gets smaller when either the confidence level decreases, right? There's a trade-off between the confidence level and the margin of error. To obtain smaller margin of error from the same data, you must be willing to accept lower confidence. Or if the sample size n increases, increasing the sample size n reduces the margin of error for any fixed confidence level. All right, some important cautions to keep in mind. Our method of calculation assumes that the data comes from a simple random sample of size n from the population of interest. So we talked about other kinds of random sampling, the stratified and the cluster. We aren't going to do that because those are too complex for us. All right. So everything we do, we are assuming simple random samples, or we have to know that. I guess we don't assume it. We have to know that. All right. So make sure that's true when you guys are doing confidence intervals. The margin of error in a confidence interval covers only chance variation due to random sampling or random assignment. Practical difficulties such as undercoverage and non-response in a sample survey can lead to additional errors that may be larger than chance variation. Okay? So always make sure you have a simple random sample and make sure you don't have undercoverage or non-response or something like that happening in your sample. Make sense? Okay, so write these three things down. When you guys are constructing random samples, you always have to check these three things. One, that you have random sampling. All right, no cluster sampling, no stratified sampling, and make sure they didn't do anything dumb like non-response and stuff like that. Okay. And two, large counts. What's the large counts rule? What do we actually do to check large counts? Yeah, that's the 10%, right? So your sample has to be less than or equal to 10% of the population. That's large counts. Okay, the only time you don't have to check large counts, you guys, is if you're sampling with replacement, which most of the time we're not. But if you are sampling with replacement, you don't have to check large counts. But most of the time we sample a group and we're not replacing them when we sample again. So we have to check the 10% condition, all right? And then we're going to check normality. When you check normality for proportions, so there's our formula for checking normality for proportions. Do we know P, the true proportion? No. So what do you think we're going to use? P hat. All right, so when you check normality, we will use our sample statistic. Yep. I think you might be right. So I got to go back and look. But either way, you're probably right. Check the 10% rule for this one. Is it not called large counts? What's it called? Is normality? I thought it was too, but I don't know. What's the name of the 10%? Did we just call it the 10% rule? Well, that's helpful. All right.
Doesn't matter what we call it.
Just make sure you do it. All right. 10% rule. And then, yes, check normality, which I guess large counts is similar. We're going to be looking at your number, making sure it's greater than 10. All right. Super short lesson today.